4.7 million. That's how many STEM graduates China produced last year. The United States produced 568,000. That's not a gap. That's not even a contest. That's one civilization systematically outbuilding another, and almost nobody in power is being honest about what it actually means. Because here's what the mainstream conversation always gets wrong. They frame this as a numbers problem. Fund more scholarships, build more universities, close the gap with a policy tweak and a press release. But that completely misses the point. China's engineering dominance isn't the result of one decision. It's the result of three interconnected systems built over 20 years quietly, deliberately, while America was distracted by culture wars and quarterly earnings reports. And once you see how those three systems work together, you'll understand why this gap isn't just large. It may be permanent. If this is your first time on GEOLOBBY, we're the channel that goes past the headline. We find the machinery underneath the story. Today, that machinery is a 20-year engineering project that could determine who shapes the next century. Let's get into it. The first system is what I'd call the selection funnel. And to understand it, you need to picture this. Every year, approximately 12.9 million Chinese students sit for the Gaokao, the National College Entrance Examination. 12.9 million people, that's roughly the entire population of Pennsylvania, taking one of the most rigorous academic tests ever designed in a single week. The Gaokao isn't just a test, it's a sorting mechanism of unprecedented scale. The top scorers get funneled into elite engineering programs at Tsinghua, Peking University, and Zhejiang. These programs have acceptance rates below 0.003%. Harvard's 3.4% acceptance rate looks almost casual by comparison. A professor at Harbin Institute of Technology once described his students to me this way. He said, "Every student in my classroom was the top performer in their entire province, not their school, not their city, their entire province of 40 million people." Think about the level of pre-selection that implies, but here's the part that gets overlooked. The Gaokao doesn't only select for raw intelligence. It selects for something arguably more valuable in an engineer: the capacity to grind through adversity across years, not weeks. These students have been preparing since primary school. Weekends, hobbies, social lives all subordinated to a single high-stakes moment. By the time they graduate university, they've already spent a decade demonstrating the exact traits that separate good engineers from great ones: systematic thinking, delayed gratification, and the ability to master complex material through relentless repetition. In America, the smartest students have options. Engineering, yes, but also investment banking, law, medicine, and a startup ecosystem that offers the dream of becoming a billionaire before 30. Talent gets distributed across multiple prestigious paths. In China, engineering still sits near the top of the prestige hierarchy. The salary premium for STEM graduates is significant, and consider this: 41% of China's Politburo Standing Committee members hold engineering degrees. In the United States Congress, 6 of 535 members are engineers. 6. When engineers run your government, engineering feels aspirational. When lawyers run your government, law school does. The selection funnel isn't just about exams. It's about what an entire society signals it values. But the funnel alone only explains how talent gets identified. It doesn't explain what happens to it next. The second system is the one I find most structurally fascinating and the most dangerous for America to ignore. I call it the industrial feedback loop. Let me ask you a question most people never think to ask: what actually happens to those 4.7 million STEM graduates after they leave university? In America, the path is relatively predictable. Engineering graduates go to Google, Apple, Microsoft, or defense contractors. A concerning share go to Wall Street because Goldman Sachs genuinely pays more than Boeing. But in China, something structurally different is happening. When I visited a manufacturing district in Shenzhen, I walked through a factory producing precision components for electric vehicles. The floor manager, a woman in her early 30s, had a master's degree in mechanical engineering. Her supervisor held a PhD in materials science. The quality control team were all engineering graduates. This wasn't an R&D lab. This was a factory floor, making brackets and housings, staffed by people who in an American company would be running a research department. That density matters enormously. China's manufacturing sector has approximately 26 engineers per 1,000 manufacturing workers. The United States has 11, but even that number understates the real gap because Chinese engineers are physically embedded in the factories. American engineers often work in corporate offices, hundreds of miles from the production line, sending specifications to manufacturing teams they'll never meet. What happens when you embed that many engineers directly into physical production? Problems get solved faster. The gap between design and manufacturing shrinks to almost nothing. A senior supply chain executive at a major American tech company put it bluntly off the record. He said, "When we send a prototype to our Chinese suppliers, they come back with 3 improvements we didn't ask for. When we send it to domestic suppliers, they ask for 6 clarifications before they can start. That's not work ethic, that's engineering density." Here's a specific example. When Apple needed a new manufacturing process for cutting strengthened glass for the iPhone, the estimated development timeline in America was 18 months. Foxconn completed it in 3, not because of inhuman labor, because they had 8,500 engineers on site running parallel experiments, iterating daily, sharing results in real time. That's the feedback loop. More engineers create faster iteration. Faster iteration attracts more manufacturing. More manufacturing creates demand for more engineers. The cycle accelerates and it compounds. Now here's the part that should genuinely disturb American policymakers. The feedback loop only works when you have the industry. You can train engineers, you can fund scholarships. But if there's no domestic manufacturing for them to work in, no factory floors, no production lines, no physical infrastructure, where do those engineers go? They go to finance, they go to software, they optimize ad-serving algorithms instead of designing physical systems. A retired GE executive I spoke to put it this way. He joined in 1985 when GE had over 200,000 manufacturing employees in the United States. By retirement, that number was under 50,000. "We didn't just export jobs," he said. "We exported the ecosystem. We exported the training ground that turns engineers into people who can actually build things." America outsourced its manufacturing to cut costs. But manufacturing was the classroom. Without the classroom, you can't produce the next generation. Without that generation, you can't rebuild the manufacturing. The feedback loop runs in reverse. The third system is the one that makes Western analysts most uncomfortable because it can't be legislated into existence, and America has very nearly lost it completely. I call it the national purpose engine. When I've spoken to engineering students in Beijing and Chengdu, there's a quality to how they describe their work that I don't hear in equivalent conversations in the United States. They don't only talk about salaries or career trajectories, they talk about contribution, they talk about building China's future. One aerospace engineering student told me this: "My grandfather couldn't feed his family. My father built roads. I will build spacecraft. That is China's story, and I am part of it." That's not crude nationalism. That's something older and more powerful, the feeling of participating in a civilizational project that transcends individual ambition. America once had this. When Kennedy announced the moon mission in 1962, engineering enrollment surged 47% in 2 years. Young Americans wanted to be part of something. They wanted to prove that democracy could achieve great things. The national purpose engine was running at full capacity, and it produced the engineers who put a human being on the moon in less than a decade. The question worth sitting with is this: what is the equivalent project today? What is the civilizational mission that makes a brilliant 18-year-old choose 4 years of thermodynamics and differential equations over investment banking? The data is stark. In a 2023 survey of engineering students across both countries, 67% of Chinese respondents cited contributing to national development as a primary career motivation. In America, that figure was 12%. The top American response was work-life balance at 58%, and look, wanting balance is a completely legitimate human desire, but engineering breakthroughs have never come from 40-hour weeks. The semiconductor industry wasn't built by people who logged off at 5. The engineers who built the American century were obsessives who sacrificed their 20s because they believed they were building something that mattered. China has constructed prestige hierarchies that deliberately funnel top talent into strategic industries: semiconductors, aerospace, advanced manufacturing, artificial intelligence. State-owned enterprises in these sectors offer what's called the iron rice bowl: stability, housing subsidies, and social prestige that compensate for lower salaries. In 2023, Huawei received 1.9 million job applications for their semiconductor division alone. Not the whole company, the chip division, because in China, working on semiconductor independence isn't just a job, it's a front line. Compare that to America's chip workforce problem. Intel and TSMC's Arizona fabs have both reported significant difficulties recruiting American engineers willing to work in chip manufacturing. The work is demanding, the facilities run 24 hours a day, and a smart American engineer can make considerably more money writing code. For a social media company, in a 2022 survey of high-achieving American high school students, engineering ranked 7th in career desirability, 7th behind influencer. The national purpose engine in America hasn't just stalled. In some ways, it's running backwards. So here's where we land. These three systems don't operate separately. They form one integrated machine. The selection funnel identifies and sorts talent with ruthless efficiency, pulling the top fraction of a 1.4 billion person population into engineering programs. The industrial feedback loop ensures those engineers graduate into an ecosystem where their skills compound daily through real-world application, and the National Purpose Engine provides the motivational fuel that makes brilliant people choose difficult, strategic work over comfortable, lucrative alternatives. Compound systems don't produce linear growth, they produce exponential growth. Every year, China doesn't just add engineers, it adds engineers who train in better facilities, work alongside more experienced colleagues, and tackle more sophisticated problems. The advantage accelerates. The numbers reflect this. In 2010, China produced roughly 31% of the world's engineering research papers. By 2023, that number was 49%, in the top 1% of most cited engineering research. China now leads the United States in 37 out of 44 subdisciplines. In patent applications, China filed 1.58 million last year. The United States filed 505,000. You cannot compete with a system that produces 10 times more engineers by hoping your engineers are 10 times better. They're not. American engineers are excellent. Chinese engineers are also excellent. When quality is roughly comparable, quantity compounds every time. So what does the next decade actually look like? There are three paths. In the first, America continues its current trajectory. Engineering enrollment stagnates, manufacturing keeps offshoring, the feedback loop keeps running in reverse, and by 2035, China leads in every strategic technology category. In the second, a major geopolitical shock forces a genuine policy response. Massive investment, restructured incentives, some ground clawed back, but the fundamental gap remains. In the third, America does something harder than policy. It rebuilds the national purpose engine. It finds a civilizational project, climate technology, space, something not yet imagined that makes a brilliant 18-year-old choose thermodynamics over trading algorithms because they want to be part of something permanent. The window for that third path is closing. Every year, the compound machine grows stronger. Every year, the cost of catching up increases. The civilizations that build things are the civilizations that endure. The ones that optimize financial instruments while others build semiconductors and power grids, they become footnotes. That might sound harsh, but I'd rather be harsh than be wrong. So here's the question I want to leave you with, and I mean this genuinely. Drop it in the comments. What would it take to rebuild America's sense of engineering as a calling rather than just a career? What is the project that could make the sacrifice feel worth it again? Because the answer to that question might matter more than any funding bill, any trade policy, any geopolitical strategy. It might be the answer that determines who writes the rules for the next century. I'll see you in the next one.